Now that we have some of those basics of polynomials down, we can kind of start classifying them, get into some of our end behavior. All right, so if I look at these problems, well, the degree, what's the highest exponent? Remember, degree means highest exponent is 2, so degree is 2. That type is quadratic, is degree 2. And the leading coefficient would be positive 1. And that looks like this graph. Notice degree 2 has 2 x-intercepts. All right, think about this. I'm going down right here, and then I get to the vertex and I start to go up. So that's 1 change of direction. Over on number 2, that's a degree of 2, which again is type is quadratic. Remember, to find the degree, I look for the highest exponent. It's quadratic. The leading coefficient is -1. Notice I have 2 x-intercepts, and notice the graph starts by going up, and then at the vertex changes direction and goes down. So there's only 1 change of direction for degree 2. Here on number 3, we have linear functions. Degree is 1 right there, so that's linear. All right, again, degree 1 right there, which is linear. Here the leading coefficient is 3, and here the leading coefficient is -2. Notice 1 x-intercept. 1 x-intercept. This one is going up and continuing to go up. This graph goes down and continues to go down. So notice it goes up and continues to go up, so it has 0 changes of direction. Degree 1 has 0 changes of direction. Moving on to number 5 and 6, they have the highest degree is 3 and 3, so that type is cubic. All right, and notice this first one, so sorry, the leading coefficients, this one is 1 and this is -1. And here notice this cubic function has 1, 2, 3 x-intercepts. When I look at number 6, notice I only have 1 x-intercept. What happened to the other 2? Well, the other 2 are 2 imaginary because they don't cross the x-axis. So 1 real, 2 imaginary on a cubic. Here I have all 3 being real. Now this case, notice for this one I'm going to go up first, then I'm going to go down. There's 1 time I've changed direction, and now I'm going to go back up. So I went up, down, up. So that means I've changed direction twice, so 2 changes of direction. On this one, which is a negative leading coefficient, I start down, then come back up, then go back down again. So notice I went down, changed it to go up, changed it again to go down. So there are 2 changes of directions for degree 3. Lastly, we have exponent of 4, degree 4, type quartic. All right, in this case, the leading coefficient is +1. In this case, the leading coefficient is -1. All right, now in this case, notice I only have 1, 2 x-intercepts. Same thing over here, 1, 2 x-intercepts. But if you follow the pattern, degree 4 really should have 4 x-intercepts, which means I have the 2 here that are real. Right there, I have 2 real. Well, if I should have 4, that means I would have then 2 imaginary on each of them to get my 4 total. Okay, now let's follow the graph. This one, it's positive. Notice I'm going up and up. On 8, when it's negative, I'm going down and down. They're both facing down, they're both facing up. That's the end behavior. All right, so if I go left to right, my parabola is going to come down. I change direction to go up, change direction again to go down, and change direction one more time to get up. So let's see here. I went down, back up. There's 1 change of direction. Then I went back down. There's another change of direction. And then I went back up again. There's another change of direction. So I had 3 directional changes. On this quartic function, I'm going to start by coming up. Right, I change direction right there. There's 1. I come back down, and now I start to go back up again. There's another one, and I go back up and I come back down. I know this one is hard to see, but that does go down and then back up, and then I change it again there. So again, 3 changes of directions. So these last 4 slides kind of get you good examples of what the different types of polynomials are: quadratic, cubic, linear, and quartic. We did those ones. And realize that every time you have the degree, if I had degree 4, that means I changed direction 3 times. When I had degree 3, I changed direction 2 times. When I had degree 1, I changed direction 0 times. So the degree tells you how many times the graph would change direction by having 1 less than the degree. Okay? Now we're going to show you something. So these 4 slides, last 4 slides, will be important to have, all right, and to remember as we go forward. Here's where we get into real end behavior, and we're going to get into descriptions of it. In that end behavior, what I'm talking about is the graph as x approaches positive infinity or negative infinity. So positive infinity or negative infinity. Okay? Meaning, what does the graph do on the ends? So it's not necessarily, I'm not worried right now about how a quartic would change direction 3 times like that. I'm really just worried about what's happening over here and what's happening over here at the ends of the graph. Or a cubic function goes down, back up, down, like that. And I'm again, what happens on these ends of the graph here. Okay? So what I want you to think about is these are going to be these 2 sentences that I have down here. Okay? And I'll make the sentences easier for you. I think these sentences are a little easier than what they have in the textbook. And so I'm just going to have it be as x gets larger, meaning as x is going to the right, what is the function doing? And then you'll fill in this part over here, all right, with your homework. And I'll show you, I'll actually give you some flip chart that you can use, and it'll make it very easy for you. And then the other one is as x gets smaller. All right, what I mean by smaller is as it goes to the left. What is the function f of x doing? Or what is the graph doing? Okay, when I say f of x, all right, I'm really discussing the graph of the function. So these are the 2 sentences you're going to have to answer for any type of polynomial. As x gets larger, f of x is approaching, in your answers here, you're going to be positive infinity, or you're going to write negative infinity in these answer blanks. So it's not only going to have most of the sentence completed for you, but there's only 2 options to fill in each blank. All right, let's look at the flip chart. So this is something you should write down, put on a card or a piece of paper or a notebook or something, and have it as a describing end behavior flip chart or your end behavior flip chart. And take a look here at this graph if it is odd and positive. What I mean by that is the degree is odd. So the degree is x to the 3rd, x to the 5th, x to the 1st, x to the 7th. Those are odd degrees. And then positive meaning the leading coefficient. So an example here would be if I had a positive number 4 x to the 3rd. Notice what the graph looks like. Cubic function like that. And I'm really looking at what are my arrows at the end. Okay? So as x gets larger, so as x goes this way, what direction is the graph going? And notice the graph is pointing up. So f of x approaches positive infinity. That's for odd positive. Any odd positive function, right? If I had 7x to the 5th, that is an odd positive function. And that would be your sentence. As x gets larger, f of x approaches positive infinity. Then we're going to take a look at as x gets smaller. Well, as x goes this way, as it goes smaller, as you look on the x value going that direction, notice this case, the cubic function is pointing down. So then I'll write negative infinity, right? So these 2 sentences, this one and this one, you need 2 sentences to describe an odd positive function. The next one is odd negative. So as an example, negative 3/4 x to the 5th could be that, okay? and take a look at how it looks. Again, I'm really worried about what are these arrows here and here going to tell us about the graph. So as x gets larger, as x approaches that direction, notice how the polynomial is going down, so I write a negative infinity in that blank. Then as x gets smaller, as x goes this way, left or less, the graph at this point is going up, so then I would write positive infinity as that. So these are the odd functions, odd positive and odd negative. Those are your sentences. Let's go look at even functions. So this is your second flip chart. If the degree is even, so x squared, x to the fourth, x to the sixth, etc., that's even. And if it's positive, you would have a positive number like 7 out in front, or 5/8 is positive, 1 is positive. All right, and again, we're looking at what does the graph do at the ends, at these arrows here. Okay, so as x gets larger, going that direction, so as I go to the right, as x goes this way, the graph is going upwards towards positive infinity. As x gets smaller, as I go that direction on the x-axis, the graph is going up, which means also positive infinity again. All right, think about a quadratic. They either both go that way or they both go that way. And our last one is if it is even, negative. So maybe negative 3x to the sixth would be an even negative function. Negative 18x to the second is an even negative function. Again, right now we're only worried about what's happening there and what's happening there. All right, so as x gets larger, as x goes this direction, it's not a parabola, the function, the graph, notice is going down. So I go to negative infinity. And as x gets smaller, as I go this way to the left, the graph is going down. The polynomial is also going down, so it's also negative infinity. So take a look at the even ones. Notice it's positive, positive when it is a even positive, and then it is negative, negative when it is an even negative. Where if you go back and look at the odd ones are alternating, all right? An odd either goes like this, so it's up and down, or it goes like this, so it's down and up. So even will always have the exact same symbols, negative, negative, or positive, positive, whereas an odd function will have positive, negative, or negative, positive. Let's look at some examples. Here is 3 examples that we'll go through. And what you can do is notice it says to describe the end behavior. So I already have the 2 sentences set up for you. So you can do this exact same thing as well for yourself. When you get an equation and it asks for end behavior, you can write your 2 sentences right away and put blank and then fill them out later. All right, another thing you can do is I call this the function flip chart, is you kind of make a little box like this, and you have odd and even, and then positive and negative. If it is odd positive, it will end positive. So positive always refers to what is it on the right side. So if it's positive, it's got to be going up on the right. If it's odd positive, it then will go down on the left. If it's even positive, it'll go up on the left. So then when I go to negative, negative will refer to what does it do on the right. So it'll be down and down. And if it is odd negative, I have up on the left, down on the right. If it is even negative, I have down on the left, down on the right. So when you look at number 1, or part A, you got to first notice it's not in standard form. So what is the leading term? Well, the highest degree is the leading term. So the degree is 3, so that is odd, and the leading coefficient is 4, so that is positive. So in this case, I have an odd positive graph. So odd positive looks like this. So it's going to be up on the right, down on the left. So as x gets larger, we are going to be going to positive infinity, which is up. And as we get smaller, that direction, we're going down to negative infinity. Notice it's odd, and I have opposing symbols, positive, then negative. And if it's positive, you go positive, then negative. All right, if it was odd negative, you do negative, then positive. All right, so let's take a look at part B. And the leading term is right here, negative 3x to the fourth. 4 is even, negative 3 is negative. So I have an even negative function. So even negative, right here, I'm going to write that down for you, even negative. And if it's even and negative, they will both go down, okay, like you see right there. Which means that case you would have negative infinity and negative infinity as your two answers. Lastly, part C, here is the highest degree, and that is number 5, which is an odd exponent. Negative 3 is a negative exponent, or a negative leading coefficient. So this one is odd negative. Okay, I never wrote down the first one. The first one was odd positive, sorry. So if it's odd negative, odd will tell you that they're going to go opposite directions. Negative will mean it'll be down on the right and up on the left. So it'll be odd negative, so negative infinity and then positive infinity. Notice when it was even, they went the exact same direction, negative and negative. When it was odd, we had positive then negative, negative then positive. So that's end behavior. This is now the full homework assignment. Enjoy and good luck.